All right, my friends, let's take a look. I've already taken the liberty of drawing region R here. Just for the record, since this would be a calculator active question, if at any time they give you function rules that you don't trust yourself to graph with a limited amount of time, feel free to just go ahead and have your calculator help you. As a matter of fact, you'll find it helpful for the purpose of this problem to go ahead and let y1 equal the square root of x minus 1 on your calculator for all the integral calculations anyway. So basically no shame in having your calculator help you graph things, basically. So hopefully you're okay with the part that I have highlighted there being region R as defined here in the first sentence. It's enclosed by the graph of y equals square root of x minus 1, the vertical line x equals 10, and the x-axis. For part A, they want you to find the area of R, so that's just a matter of setting up the correct integral. So we're going to use the idea of upper minus lower. So the upper function is square root of x minus 1, and the lower function is 0. So your integrand would basically just be the square root of x minus 1 dx, and then the bounds, we would be adding these little areas of rectangles starting at 1 and stopping at 10. There you go. Okay. Using your calculator, simply by, if you've already programmed square root of x minus 1 as y1, then you could go to math, function integration, use y1 as your integrand, integrate with respect to x and make your bounds be from 1 to 10. You should get 18, and then it's area. So let's keep it classy and say units squared. There we go. Okay, moving on for part B here. Find the volume of the solid generated when R is revolved about the horizontal line y equals 3. So here's y equals 3. And then I'll just try to graph that reflection. Over that rotational axis. And then I'll try to draw the kind of 3D look that we would get around the outer edges. And then always including like a typical cross-section from somewhere in the middle. Okay, from here you could look at, kind of your typical cross-section and labeling your inner and outer radii. So the outer radius, and I hope it makes sense, this should be a dx integral since you want to accumulate these washers starting at 1 and stopping at 10 on the x-axis. So what would a good equation be for the outer radius? So let's think this out. So the outer radius would be the distance from the axis of revolution. Always go back toward your original region, my friends. That's why I've been having you shade it. So go from your axis of revolution all the way down to the outside of that washer, okay? And it looks to me like that would be consistently 3 units. Okay, no matter where that washer would be in this region, that radius would always be 3 units. I hope that makes sense. Okay, now your inner radius, however, that would vary depending on where the washer is, so we should get a function of x for that part. Okay, now think this through with me. The distance from the x-axis up to the square root graph, that's the square root of x minus 1. But we want this distance that's between the axis of revolution and that graph. So that little distance would be 3 units, take away the square root of x minus 1. I hope that makes sense, okay? If it doesn't, make sure you ask me about it, okay? So now the plan is basically just to set up a volume equation, and the volume equation is just adding up infinitely many, infinitely thin of these little area functions. The dx takes care of a little bit of heft there. And so the setup could be something of the form pi times the integral from 1 to 10 of the outer radius squared, take away the inner radius squared with respect to x. Okay, up to you how you want to go about this. I'm just going to go ahead and make my calculator do the work. And it looks like I get, I'll go ahead and say approximately 67.500 pi. And then that would be cubic units. And let's go ahead and multiply pi in as well. 212.058 units cubed. There we go. Either of those answers would be considered the correct answer. There we go. Okay. Part C, find the volume generated when R is revolved around the vertical line, x equals 10. At one time I thought I'd draw that on top of the original picture, but I'm kind of changing my mind. It would get pretty cluttery. I suppose you could if you want to. So I'm going to go ahead and draw kind of a shorter version of it. Okay, so there's your axis of revolution at x equaling 10. Now we're going to revolve this around, let's see, so we hit here at what, 19, I guess. Okay, and then we'll just kind of add the 3D look to it. You could always add one in the middle. Let's see. So for this problem, if you take your slices perpendicular to the y-axis, then you could see that you'd have this known cross-section, and I hope it makes sense that this known cross-section would be a circle shape. So if we can get the formula for the radius in terms of y, I hope it makes sense. This would be a dy integral, since your known circles there would be what you'd have to be slicing perpendicular to the y-axis in order to get those circles. So we need this radius here to be in terms of y. Okay, so let's figure that out. Keep in mind the equation of this original graph. Always go back to the shaded region, that original piece there. The equation is y is equal to the square root of x minus 1. You could, of course, square both sides and then isolate x, which would be a move in the right direction. So x is equal to y squared plus 1, or something to that effect. Okay, now be careful though, because this expression right here gives you the x coordinate that it takes to get there. So this distance from the y-axis over to that point on the outer edge of your graph, that's equal to y squared plus 1. But we want an expression for this distance right here. Okay. Yeah, that distance right there. So how are we going to get that? Well, we're going to take this whole distance, which looks like it's 10 units, and we're going to take off that y squared plus 1 to get the remaining piece. So it'll be 10 minus y squared plus 1 for that part right there. All right, you could simplify it or not. I'll just go ahead and show the unsimplified version. And then from there, you could, of course, simplify it. Totally up to you. Nobody really cares for these. All right, my friends. So the volume then would simply be, so these are circles. So we're going to add up a bunch of pi r squareds. So pi times the integral from, keep in mind, it's a dy integral. So scan the y-axis from negative to positive. So that's bottom to top. So from 0 to 3, hopefully that makes sense, of 9 minus y squared, that's the radius. So you need to have a bunch of pi r squareds in there. There you go. All right, so now just kind of punching this into your calculator, I would just kind of enter it in directly. So the integrand is 9 minus. You can go ahead and use x instead of y. Your calculator wouldn't know the difference. Integrate with respect to x. Make your bounds be from 0 to 3. It looks like I end up with 129.6 pi, or approximately 407.150 units cubed. All right, my friends, I want to make sure that everybody knows how to find scoring guidelines when you need to look them up. It's actually super easy. So you just type in 2004. Make sure that you realize that until I say otherwise, we will be using AP Calculus AB material, and then type in the word scoring guidelines, okay? So it's a Google search, easy thing, okay? And then make sure that you select something that says Form B, and then all you'd have to do is scan through the questions looking for something that is similar to what we've been working from. So there you go. Anyway, so you can see the question at the top, and then on the left side, they're showing you what typically what they're looking for. They won't be showing you all the work necessary really to do the problem. They're just showing you kind of like the parts of the work that they would be awarding points for. And then in the right category, in the right column, you can see where the points are from. Okay, each FRQ adds up to 9 points, and so so we'll go through and kind of show you where the points came from in just a sec here. All right, my friends, so let's go through and we'll talk about where the different points were for and how to interpret the descriptions for where the points come from. Okay, so in the scoring guidelines, when they say limits, they're actually talking about the bounds. So for part A, it said 1 point for limits. So what that meant was that they're going to give you 1 point for saying from 1 to 10. Okay, if you had the right bounds, you get the point. If you don't have the right bounds, you don't get the point. And then there was 1 point for getting the correct integrand. So that would be the square root of x minus 1 dx. So 1 point for that. And then 1 point for getting the correct answer. And your final answer has to be accurate to the thousands place. So you could either write 18 or you could have written 18.000. In the math world, we all know that's the same thing. Okay, so that's the 3 points for part A. For part B, they gave you, it said 1 point for the limits or the bounds. Actually, no. It was 1 point for the, sorry, oops, let me put that back. Oh dear. It was from 1 to 10, wasn't it? Okay. It was 1 point for the limits, as in the bounds, and then also the constant, so the pi. The pi could be inside the integral or outside, but 1 point for that part. And then it was 1 point for the integrand. And then 1 point for getting the correct answer accurate to the thousands place, and either of these versions would have been fine. Okay, for part C, it was the same thing. So 1 point for the limits and the constant. 1 point for the integrand. And then 1 point for the final answer, accurate to the thousands place. And either of these answers would be fine for that in terms of pi or not. I encourage you to always do both so that you don't have, so you have that habit of muscle memory of showing both. So there you go. So it adds up to 9 points. Go ahead and put your original score out of 9 points. If it's low, don't even worry about it. It will go up as we practice. But go ahead and write what your original score was out of 9, and then you could kind of, if it makes you feel better, you could show what your score is, after we've gone through the edits, and show that you did turn it into 9 out of 9 after going through it with me. So, all right, hopefully this makes sense. Hopefully you're off to a good start. Take care, everybody.